So chapter 11, Understanding Randomness. Random, so we're going to start with some vocabulary, and then we'll do some examples of simulations. Random, an event is random if we know the possible outcomes, but not what did or will happen. This does not mean that the outcomes are equally likely to happen, meaning the probability of them happening is equal. It just means we know what's possible, but we don't know what's going to happen. For example, rolling a die, right? Shuffling a deck of cards and pulling a card out. Spinning a spinner. A simulation models random events by using random numbers to specify event outcomes with relative frequencies that correspond to the true real-world frequencies we are trying to model. So sometimes it's not always possible to perform the random event and find that probability in real life. Sometimes it's expensive. So we perform what's called a simulation to try to estimate probabilities. The outcome is the individual result of a simulated component of a simulation. And a trial is the sequence of events that we're pretending that will take place. So we're going to model, we're going to simulate shooting free throws. Okay, the outcome is whether we made the free throw or not, and the trial is how many we made in 5 attempts. We have a certain set of steps that we follow to make sure our simulations are complete. The first thing we have to do is identify the component that we are repeating. Are we simulating flipping a coin? Are we simulating buying a box of cereal and did I get the toy that I wanted? The collector's spoon from the Frosted Flakes? Explain how you will model the outcome and how you will simulate the trial. State what the response variable is. And run several trials. Analyze the response variable and state your conclusion. Now the response variable is what we're interested in the end. Are we interested in the percent of shots we made out of 5? Are we interested in the average number of attempts before we missed? That's your response variable. And then we actually calculate that in step 6. Okay, so we're going to talk about tossing a coin. What would it take you to convince you that a coin that we were tossing was unfair? Where do you draw the line between reasonable behavior and an outcome so strange you think that something is wrong, or it proves to you that that coin is not fair? So we're asking ourselves, if I flipped a coin 100 times, how many heads would it take to convince me that this was an unfair coin? Okay, I heard someone say 10. There was only 10 heads that it would convince you that the coin was unfair. I heard someone say 98. What's your number? Call it out.
I changed my mind
To 20? I need some numbers. We need a dot plot here so we can compare what we think to what really is unlikely. 42 heads would convince you that it was not a fair coin?
No.
80, 95. I'll put 42 on here, but that's only 8 from 50-50. That's.
Is it like in a row?
Yeah. No, just out of 100.
Oh, I thought you meant in a row.
No, not in a row. Out of 100, so I'm taking that off. Okay, let's think again. Out of 100 tosses, okay, if you got how many heads would make you say, wow, that was a lot of heads, this might be an unfair coin? Or that's not very many heads, this might be an unfair coin. Okay, so I'm hearing 80, 85, 66, 75. Someone said 20? I need more numbers. I need a good dot plot here. 15? 0. Yep, 0 would convince you. But I'm not asking a yes. If there was 0 heads or 100 heads, we would be convinced it was not fair. What is what is that number that if it was this number or more, I would be convinced? Like, yes, 100 would convince us that it was not fair. But this number or more, yeah. So what's like the smallest number of heads that would convince you that it's not fair? 65. 77. 80. Another 80. 70. 75. 90. It would take 90 heads to convince you that it's not fair. Okay. Are there any numbers that I need to add to this? So we're going to perform our first simulation, so get your calculators out. We're going to flip a coin. We're going to flip a coin, a fair coin, 100 times. We're going to use the function randint. Randint is in Math, Prob menu. Okay. We're going to go into the Math menu. So hit the Math button. It's below alpha. Hold on. In the Math menu, over to probability, we have a function called randint. Randint gives us a random integer from whatever 2 numbers we tell it. So when I was grading your group quizzes for chapter 6, I put in 1 through 4, and it randomly told me which quiz to grade, right? Because there was 4 of them stacked together. If I got 3, I graded the 3rd quiz. So I'm going to do randint 0, 1, and we're going to let 0 be heads and 1 be tails. Okay. And we're going to paste. And I'm going to hit enter, and I got 0. That means I got what? It was just 0 and 1. The n I left is 1. Okay. Yeah, you should be getting something different. Your calculator is randomly deciding whether you're getting a 0 or a 1. So everybody's going to get either a 0 or a 1, but you're not necessarily going to get the same thing as me. Right? It's like flipping a coin. If you all flip the coin at the same time, we're not all going to get heads. Okay, so our calculator is randomly choosing. Now, if I wanted to do it 100 times, I can put 0, 1, 100. I can do 10 if I wanted. Let's do 10 first. This is telling it how many times to toss. And if I hit enter. Yeah, wait, what did I do? I messed up my... There we go. There's mine. So I got tails, 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 heads, heads. Okay, so we did a simulation. We tossed a coin 10 times. You got different results than me. I got tails, 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 heads, heads, tails, tails, heads, heads, heads. Okay? In 10. The problem is if we do this 100 times, we have to go through 100 and then count how many zeros there are, right? So there's a way in the calculator to do this 100 times and have it add up all the numbers, 0 or 1, right? If I get the sum, right, the sum of this would tell me how many tails I got, right? And then if I want to know how many heads, I can subtract from how many I did. So this sum would give me 5, right? 5?
Yes.
5 tails. Okay. So we are going to, I got to figure, hold on. Every year I forget where the command is. Okay. So in my calculator, we're going to go and find the sum function. So hit second stat. Above it, it says list. Second stat. Go over to math. Go down to sum. Second stat, that's in list, over to math, down to sum. Okay, hit enter. Now we're going to go math, probability, randint, 0, 1, 100, and paste. Now it's going to add up those 100 numbers for us. Okay, so remember that the number we get is the number of tails because we said 1 is tails. But if we said 1 is heads, then it's the number of heads. It doesn't really matter what we assign that random number to. So I got 44 heads. I got 44 tails, sorry. That's 44 tails, which is 56 heads, right? So let's create a dot plot for our answers. Okay, I got 56. Abigail, what number did you get? Or what is your heads? So 53? Charlie? 53 heads?
Yes.
Your calculator's dead. To know?
Which one is that? Is that the 0 or 1?
What the number you got? How many? 27? 47. Was that your heads or your tails? Okay, so 53. Claire? What number did you get? So 51. Morgan? 52. Sophia? 51. Caitlin? 53. 51. 41. 49. 60. 50. 58. Valerie? 53. Emily? 51. Rogelio, 55. Layla? 53. 53. 45. 53. 47. 58. 48. 64. Aiden? 49. 53. Okay, look at our data. This is what? It's unimodal? It's symmetric, right? The center is about 53, right? That was our peak. So we were caught up on, yes, if you had 70 heads, that's unlikely, right? We just did 33 simulations. Nobody got higher than a 64 heads, right? If we kept doing it, what do you think is going to happen? Do you think it's going to stay clustered here? Yeah. Why? Because the actual probability of getting a heads is 50. So how many do we expect out of 100? 50, right? We expect 50 out of 100. Yes, we know it's going to vary a little bit, right? And so with these simulations, they can help us model a real-world situation and get a probability of something happening without having to actually flip the coin 100 times and record it. Okay? So the point of this is that our idea of what's unusual, right, 80, 90, that would convince me, is usually much different from reality of what is unusual. Okay? So here is our first simulation that we're going to do together. Okay? Suppose a basketball player has an 80% free throw success rate. How can we use random numbers to simulate whether or not she makes a foul shot? How many might she be able to make in a row without missing? Describe the waiting time simulation of having her shoot free throws until she misses. Waiting time simulation is doing something over and over until something specific happens. So we're like shooting those free throws until we miss. And how many can we shoot in a row before we miss? Okay? And we're actually thinking in a mindset of every number represents taking that free throw. So what are we? We are simulating free throws. So the first thing, identify the component to be repeated. I'm going to label it 1, 2, 3, 4, 5, 6, and 7. So we recognize what step it applies to. Okay? So step 1, we are repeating shooting free throws. Explain how you will model the outcome is how are we going to use the digits on the random digit table in order to represent making a shot and missing a shot. Okay? We have digits 0 through 9. Those are the digits, right? 10 is not a digit, 10 is a number, right? I need 2 numbers to make 10. I only need 1 number for 0. So 0 through 9 is 10 digits, agreed? Yes, okay, because 0 is that 10th number. So when I have something that has an 80% probability, I need 8 numbers, 80% of my numbers, to represent making the free throw. Okay, so 80% probability means 8 of the 10 numbers. So I'm going to say we're going to let 0 through 7. Is that 8 numbers? Yes, right? 0, 1, 2, 3, 4, 5, 6, 7. That's 8 numbers. B, she makes the shot. And 8 and 9, B, she misses. Is that 20% chance that she misses? 80% chance that she makes it means 8 numbers need to represent that she makes the shot, and 2 numbers need to represent that she missed the shot. Okay? And I can use single digits because 80% is 80 is a multiple of 10. Faith.
So I understand like the 0 counts for like a digit or whatever. Mm-hmm. Why did you use like 0 instead of like 1 through 10?
Because if I'm using a random digit table, okay, I'm using the digits. If I wanted to use 10, I need 2 numbers to get 10. Right? So I want to use the least number of digits together at a time. There will be a time where I need to use the random digit table 2 numbers at a time. But my random digit table is filled with numbers 0 through 9, right? They randomly generated numbers 0 through 9 in each of these sets, okay? There's no like 10 kind of separately together. In order to find a 10 in here, I would have to find a 1 with a 0 next to it.
Oh, so the way we're determining if she makes a shot is if the number on the table is 0 through 7.
Correct. So we're going to look at the numbers on this table, and if it's 0 through 7, we're going to say she made the shot. And if it's 8 and 9, we're going to say she misses it. Okay? I want to use one digit at a time if possible, but that's only possible when my percentage, my possibilities, is a multiple of 10. 10%, 20%, 30%, 40%. Once it gets to like 77, now I've got to use two numbers at a time. Okay? So I would make it from 0, 0 to 79. And that would be 80 numbers if I was using two digits at a time. Right? And we'll do one that uses those next. Okay? So the numbers on the table represent whether or not she makes the shot. So, hold on. So this is how we're modeling the outcome. That's number 2. Number 3 is how are we going to do a trial? Okay? So we're going to use a random digit table, an RDT, random digit table, okay? Oh, I don't want to put that there. I need that space. RDT is random digit table. Okay? One digit at a time, right? We're going to use it one digit at a time. Okay? So we're going to go one number at a time on our random digit table, and we're trying to simulate how many shots she makes before she misses, right? It says, describe the waiting time simulation of having her shoot free throws until she misses. Okay, so what are we counting? How many shots she makes before she misses it, right? Counting the number of shots made till she misses. Our response variable is the average number of shots made till she misses. We can't calculate a percentage. We're trying how many until she misses. Right, so there's always going to be one miss and then the number that she makes. So we have to find an average of that. And we're not going to just do it one time. We're going to repeat the trial over and over again so we can get a good idea of how many she's actually going to make. Right, so now we're going to run the trials. At least 10, 20 is better. Your book will tell you how many trials to run. Okay, so this is the important part of how to use the random digit table. Okay, the first number, okay, I can actually choose any random digit line I want. Okay, we're going to start with 101. You will not use 101 again for a homework assignment. You will go down to 102, right? So you're not going to reuse it. So we're going to mark up on our paper. So you should have this in front of you and you're marking on it. Okay? So do we want to put a Y for she makes it and an N for she misses it? Because we can't use M and M. Right? So we're going to put a Y every time she makes it. Okay? So 1, did she make her shot? Yes. So the first number, 1, she makes it. 9, she misses it. My trial is over. She missed her second shot. How many till she missed it? 1. Next trial. 2, did she make it? 2, does she make it? 3, does she make it? 9, does she make it? Okay, trial's over. How many did she make? 3. So you don't always have to write on top of everyone either. But, I mean, that's just so visually we can see what we're doing. Okay, 5, did she make it? 0, did she make it? 3, did she make it? 4, did she make it? How am I determining that? We said any number between 0 and 7 is a made the shot. If it's an 8 or 9, she misses. Right? So we're just looking until we get to an 8 or a 9. And she makes it, she makes it, she makes it, she makes it, she makes it. She makes it, she misses. Right? I have all numbers 0 through 7 until this 8 here, which means she missed it. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See why we do more than one simulation? If we just did the first one, we'd say, oh, she sucks. Her average was 1. No, right? That's not what's going to happen every single time. So we have to simulate doing it over and over again. Okay? Now next line or next set, next trial. We've run 3 trials. Okay? Did she make it? 7? 1? 3? 9? No. She made 3 again. Maybe 10 is an anomaly. Maybe the 10 is in the outlier, right? Next trial. Yes, 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 no. 3 again. Next one. Yes, 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 yes. Those are all yeses, right? Now what do? I go to the next line. Okay. Huh? Oh, sorry. I didn't. No. Okay, so that was 10 again. Next. Made it, miss it. 1. Next one, yes, yes. Go to the next line. Yes, 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 yes. Missed it. How many was that? 2, 12. Right? Next one is 0. So we're at 1, 3, 10, 3, 3, 10, 1, 12, 0. Those are our trials so far, right? How many she made before she missed. I'm just copying down the numbers that I wrote up here. So eventually I can make sure I get 10 of them. Next one is 4. Did she make it? 0? 0? 0? 1? No. 9. 5, right? Okay. And then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 trials, we'll call it. So we ran our trials. That was number 5. Number 6 is analyze the response variable. That means calculate the average or the percent. Whatever the problem asks you, we're going to calculate her average number of shots made before she misses. 1 plus 3 plus 10. Plus 3 plus 3 plus 10 plus 1 plus 12 plus 0 plus 5. Divided by 10. Divided by the 10 trials. That's 48 over 10, 4.8. 6 was analyze the response variable, which means calculate the percentage of times she made more than 3 in a row. Or, because in this case, our response variable is the average number of shots before she missed. Okay? So it can be different for different problems. Caleb?
So on average, you made 4.8 shots before a miss?
Yes. And we don't need to round that because we're talking about an average. Okay? We realize averages aren't always perfect numbers. Right. But that can be her average. Right? Her average can be 4.8. Right? So we say based on our simulation, everything is only based on this simulation that we just did. The greatest part about this homework assignment is I'll know if you're copying because everybody should be getting different answers depending on how they set up their simulation. The back of the book is going to say answers may vary because they're supposed to. You're supposed to get a different answer from the person next to you because you're supposed to be using different random numbers. And could I have set this up instead to say that 0 and 1 is a miss? And that 2 through 9 was a make? Sure. Right? So everybody, could I choose 5 and 6 to be a miss? And all the other numbers to be a make? Sure. That makes it harder, but I can do anything in how I set them up as long as they correctly represent the percentages. Caleb?
So you can make 2 and 8 for missed shots, or does the number have to be right next to
Nope. I can make any two of the 10 numbers, right? That usually makes it harder because I have to think more when I'm going through my random digit table, right? Like, it's easier to say 8 and 9 or 0 and 1 because you're looking for those numbers at the end, and it's easier to count it that way. Okay, so I don't recommend saying, oh, I'm going to make 2 and 5 be a make or a miss, right? That's just too complicated. So we say based on our simulation, we can expect her to make an average of 4.8 shots before she misses. We're always saying based on our simulation, this is what we would expect. We know that if we actually went into the gym with her, we're going to get different info, right? Another set of 10 trials is going to give us a different average. Okay, so we're just saying, based on this simulation, we're never making a statement that says this is what will happen with any certainty, because we know that there's randomness and it's going to change every time. Right? So if you don't say based on my simulation, you get it wrong, because you're making a very concrete statement. How would this be different if I was using a calculator? Instead, I would say use randint 0,9. I want digits from 0 to 9, right? Those are the numbers I'm using. 0 through 7 is a make. 8, 9 is a miss. Counting number of shots till there is a miss. So I have to state that I use the calculator. And we're going to go math, probability, randint, 0, 9, 1, and paste. Okay, so this is a miss. So my first trial is 0. Oh, let me write on the side here. My first trial was 0 because it's a 9. That means she missed her first shot. Yes, Ava. Yep, I'm just going to hit enter again. So she made it, right? Hit enter again. She made it, that's 2. She made it, that's 3. She made it, that's 4. She made it, that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, holy crap, 28, 29, there we go, 28. Okay, so my second trial was I was just hitting enter and counting until I got an 8 or a 9, right? So she made 28 shots because on that 29th button, she got a 9, right? And then you do it again. 1, 2, 3, 2. Okay. Then you do it again. 1, 2, 1. She made 28 in a row. And now she can't make more than 2. 1, 2, 3, 2. Okay, and then you keep going until you have 10 trials recorded as well. You do not need to write down every number that comes out of your calculator when you're doing it. And you do not need to write down on your homework the numbers on the random digit table. Okay, so you don't need to go through and write 708 on your paper. You're just going to write 2 because she made 2 and then missed it. Okay? And you don't need to copy these numbers onto your homework either. That's too much work because on a quiz or test, you'll be given the numbers to just write on. Okay? You don't need to recreate, repurpose them, rewrite them. Okay? And so everything else is the same when I'm using a calculator. Okay? We're going to, what if, instead of her free throw rate being 80%, what if it was 77%? How does it change what we're doing? Okay, so this is for, we'll call this A. If it is 77%, we are still simulating shooting free throws, right? Instead of 0 through 9, I can no longer use 0 through 9, right? There's no way to take 10 numbers and then divide that up into 77%, right? So I need 100 numbers. Okay, if I'm going to use 100 numbers, I need to use 00 to 99. I don't want to use 100 because that's 3 digits at a time. Okay, and I want to stick to only 2 numbers at a time. Because if I'm doing from 1 to 100, then I have to ignore every 3-digit number above 100, and this is going to take me a really long time to get through my random digit table. So I want to stick to 1 digit or 2 digits. That's why we use 0 and 9 or 00 to 99. Faith? Yes, 10 to 20. Your book's going to tell you if it wants you to do 20. Okay, so if it's 77%, okay, I need 77 digits, 77 numbers, which is 00 to 76. Yes? Because 00 is that 77th number, right? So I have to decrease it by 1 because I'm counting 00 as that first digit, that first number that represents she made it. And then 77 to 99 misses. She misses. And then we're going to say, use the random digit table 2 digits at a time. If we're using the calculator, we're going to use randint 0 to 99. Okay? So we're either using the random digit table 2 digits at a time. It's very rare that we use the random digit table more than 2 digits at a time. Okay? Or we're using randint 099. Counting, it's both. We're still counting the number of shots she makes before she misses. Okay? So all we've done is kind of change the number sequences, not how we're performing this trial. Okay? And then wait. I do want a picture. Let's say we start with line 4. Okay, we'll skip line 3 because it gives us space to write. So now our response variable is still average number of shots made in a row, right? That didn't change either. So now we're going to go 2 digits at a time. It's sometimes a little bit more complicated because you have to think a little bit harder, right? We're looking for 77 to 99 means she misses it. So my first number is 52. That's a make, right? So that's a Y. Next number is 71. That's a make. Now the next number is 13. Okay? The gap is just there to make it easier to see the separation. Okay, so that next number is 13. Did she make it? And the next number is 88. That's a miss. So then my first trial is 3. Okay? What's the next number? 89. That's a miss. So that's 0. Next is 93. Also 0. Now this one is 07. So that's a yes. 46. Also a yes. 02. Yes. 27. Yes. 40. 01. 18. 58. 48. 48. 76. Ooh, that's close, but that's still a make. 75 is still a make. 25. 73. 95. The next one is a no. Okay, so how many did she make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my next trial is 14. Okay, so that's the twist. How do we use it 2 digits at a time? How do we write that? Okay, we'll talk next about what if we were doing a different situation, not how many till she misses, but how many does she make in 5 shots? So there's a set number of trials. What's the average number of shots she makes out of 5? Okay, that we're going to talk about next.